Welcome to our video on section 3.4 of the Red Book, using equations to solve world problems. So in this section, we are going to follow this process. We're going to identify the variables, translate to set up an equation, solve that equation algebraically, and then answer the question that was asked in a complete sentence. So that's the process that I will model, and that's the process that I would like you to follow when you're solving word problems. So of the 8 questions here in your notes, I'm going to demonstrate 5, and I'm going to leave 3 for you to do as practice. So our first question, the sum of 8 and 3 times the number is 128. Find the number. So when I see the phrase find the number, I know that my unknown, or what I'm looking for, is the number. So it's easy to define my variable. I want to remember my translating skills, of course. So when I hear the word sum, I think of addition. When I hear 3 times, I want to think of multiplication. And when I see the word is, I want to think about equals. So using all of those skills, I'm going to get the sum of 8 and 3 times the number is equals 128. That's my translation and my equation. And now I solve using my inverse operations that we've been working on. So I subtract 8. I then undo the multiplication by dividing by 3. And I have that x is equal to 40. So again, all they were asking for is the number. So answering in a complete sentence, I would simply say the number is 40. So that's a nice, straightforward problem to get started with. Let's go ahead and look at number 2, which is similar, but a little bit more challenging. So again, 4 less than half a number is 15. Find the number. So we have that phrase again, which means that we're just going to make x the number. But we want to think in terms of when we have 4 less, that's going to be subtraction. Half of a number, so half of, when I think of half of, oops, I wanted to do that in a different color. Let me just erase that. And if we have half of a number, then I want to think about that being multiplication. So it's going to be half of, and then we have, of course, again, the word is our equals. So let's go ahead and put that all together. But remember, order matters with subtraction and division. So when we read 4 less than half a number, we want to start with half of the number and then take 4 less than that is 15. So if we turned the order around, 4 minus 1/2 x, we would not get the correct answer. So now we're going to use our inverse operations. Because it's minus 4, we're going to add 4. And because I have a half times the x, I want to use the reciprocal and multiply both sides by 2 over 1, or 2. So I'm going to multiply both sides by 2, and I'm going to get x is equal to 38. Again, the number is 38. Easy sentence. So what's tricky about this one, of course, is that we have to be careful of the order with division and subtraction. So I'm going to leave the next practice problem to you, and you can fill in the answer in the question that will pop up in the video. All right, so let's move on to consecutive integers. So we want to recall that integers are whole numbers and their opposites. So I'm going to just write down integers, no fractions or decimals. It's important to remember that. So if we're talking about consecutive integers, we might be talking about the numbers 1, 2, 3, or 4, 5, 6. So as you can see, they're right after another. We want to almost think of numbers that are on a number line. Of course, they can be negative as well. It could be -5, -4, -3. So I'm just going to give an example here of 8, 9, and 10. If we were trying to come up with unknowns to represent them, if we started with the smallest number as x, then the next one would be x plus 1, and our third number would be x plus 2. If we had a fourth number, that would be x plus 3, etc. Now, if I change one word, or add a word, I should say, from consecutive integers to consecutive even integers, then my example numbers might be more like 8, 10, and 12. Now again, if I start with the variable x, to get to the next integer, I would want to add 2. So from 8, I added 2 to get to 10. And from 8, I would have to add 4 to get to 12. So my unknowns, or my variables, would be x, x plus 2, and x plus 4. Finally, let's look at an example of consecutive odd integers. Now, this is the one that gives students the most trouble, and I'll explain why. So if I use the integers 9, 11, and 13 as an example, I would start with the variable x for 9. And students naturally think they should add an odd number if they're consecutive odd numbers. But if you're starting with 9, think about what number would you add to 9 in order to get 11? Well, that's going to be a 2. So we would use x, x plus 2, and then to get to 13, we would add 4. And again, if we had a fourth number, it would be x plus 6, etc. All right, so that's a little intro into consecutive integers, consecutive even integers, and consecutive odd integers. Let's go ahead and put that into practice by doing number 4. Find 3 consecutive numbers whose sum is 13. So I'll point this out that we see the word numbers, and then we'll come back to that after we solve. So I'm going to use those unknowns that we identified. If we have 3 consecutive numbers, then if x is the first number, then I would need to add 1 to get to the second or the next number. And in order to get to the third number, whoops, I said 3 and then wrote 3. That was a big mistake. I would add 2 to get to the third number. So I have my 3 unknowns, and we want the sum is 13. So what I'm going to do is I'm going to say x, the first number, plus x plus 1, the second number, plus x plus 2, the third number, is or equals 13. Now, some of us probably could have done this one in our head. Actually, not so much when we see what we end up with, but in terms of getting the equation. What we're going to do now is we're going to identify our like terms. We have an x plus an x plus an x, which is going to lead us to 3x. And we have a positive 1 and a positive 2, which is going to lead us to plus 3. So now when we solve, right, we're using our inverse operations, and we're subtracting 3 first to get 3x is equal to 10. And then we're undoing the multiplication by dividing by 3. And what we end up with is x is equal to 10 thirds, or 3 1/3. Now, that means that if we go back to our unknowns, if x is 3 1/3, then if we add 1 to 3 1/3 for the second one, then we would have 4 1/3. And if we add 2 to the first number, then we're going to get 5 1/3. So the numbers are 3 1/3, 4 1/3, and 5 1/3. Now recall at the very beginning that I highlighted the word numbers. That's because if this had been changed to integers, what would our answer be? Well, the answer would be no such numbers exist, because when we solved, we didn't get integers. We got numbers, we've got rational numbers that can be expressed as a fraction, but we did not get an integer. So that's just to pay attention to words. All right, so number 5 is going to be a practice problem very similar to what we just did, and you'll be able to put your answer in the answer box. Okay, now we're ready for number 6. So Sam has $140. If he saves $2.50 per week, how long will it take to have $200? So I sometimes refer to these as a fixed plus variable because it says that Sam has $140. That's a fixed amount that he has, and we can't take it away from him. But then we say, oh, well, the $250 per week, this varies. Okay, and then we want to know how long will it take to have $200. So the how long is going to give us a clue about what we're going to use for our unknown. Our unknown, since they're asking us for how long, and because we're saving in weeks, is going to be the number of weeks. So when I say fixed plus variable, the $140 belongs to Sam. No one's going to take it away from him. So we're going to start with that, and then we're going to say, oh, every week he adds $2.50. So if we multiply by the number of weeks, we're going to get how much he's saved. So for example, after 2 weeks, he's got $5. And we want to get to a total of $200. So the fixed plus the variable equals the total. All right, so now we're just going to go ahead and solve using our inverse operations. So we're subtracting 140. And again, you're going to take out your calculator probably for this, or we could convert it to a fraction. Again, if we take out our calculators and put in 60 divided by 2.5, we're actually going to get an integer, so it's going to come out nice. And so here we're going to end up with 24 weeks. It takes, oops, I can't spell, but it takes Sam 24 weeks to save $200. I could certainly finish that. All right, our last question type and our last sample for today is a geometry question. So then you'll have one to practice. The width of a rectangle is, I'm just going to mark that right away because we know that's our equals, 12 centimeters less than its length. The perimeter is 120 centimeters. Find the length and width of the rectangle. So I am going to, whenever I see a geometry question, I'm going to go ahead and draw a shape so that we can actually visualize our rectangle. And so now that I have that, I'm just going to label it. It says the width is 12 centimeters less than its length. So it looks like if x is our length, then, and again, I'm not sure if that helps us too much by putting 12 less than the length is the width. So I am going to say that x is my length, and the reason I'm using x instead of L is because I find L a little bit tricky. It sometimes gets confused as a 1, and of course I just made a mistake there. So, all right, so we have length and width identified. Now notice I put both of those as unknowns because it's asking us to find both the length and the width of the rectangle. So we want to identify both of those unknowns. Now, the perimeter is 120 centimeters. So that means that we need to know the formula for the perimeter. So perimeter is 2 of the widths plus 2 of the lengths is equal to perimeter. So what I'm going to do now is put in what we have used for length and width into the formula. So we have 2 of the widths. Now remember, you need to use parentheses here because the width is not just x, but it's the quantity of x minus 12. And 2 of the lengths, we're just using x, and the perimeter was given as 120. So now we have our diagram, we have our variables, and we have our equation. All we're going to do now is go ahead and solve algebraically. We've, of course, learned a lot about the distributive property at this point. And we know how to combine our like terms. So we have a 2x plus a 2x. And of course, we want to simplify one side of the equal sign before we cross over. Now we're isolating our variable. And when we undo that multiplication by dividing by 4, we get x is equal to 36. So the question asked us for both the length and the width. So if our length is 36, then 36 minus 12 would be 24. So the length is, and of course we want to use our units, is 36 centimeters, and the width is 24 centimeters. Usually our widths are less or smaller than our lengths. All right, so our last question, number 8, is very similar to what we just did, and I'll leave that for you to finish and write in your answer. So this concludes our video on section 3.5. Oops, sorry, I said the wrong one. 3.4, using equations to solve word problems.